What if I told you that the key to our green energy future isn't just in the sun or the wind, but deep inside the fiery heart of volcanoes? It sounds like science fiction, but today on G Fun Facts Online, we're talking about a revolutionary technology that's turning volcanoes into a source of both clean power and the critical metals we need to build that future. Get ready, because we're about to dive into the world of volcano-powered mining. We all know the world is shifting towards a low-carbon economy. That means more electric cars, more wind turbines, and more solar panels. But here's the catch. All of that green tech requires a massive amount of metals, like lithium, copper, and cobalt. And how do we get those metals? Through traditional mining, which can be tough on the environment, tearing up land, and using huge amounts of energy and water. It's a classic paradox. To go green, we rely on a not-so-green process. But what if there's a better way? Enter the volcano. Well, sort of. We're talking about geothermal energy. In volcanically active areas, the Earth's core heat is much closer to the surface. Rainwater seeps down, gets superheated by magma, and becomes hot, pressurized brine. For decades, we've used this steam to spin turbines and create clean electricity, but scientists realized this hot water is doing something else. As it circulates, it's leaching minerals from the rock, essentially becoming a rich, metal-filled soup, a liquid ore. The big idea is to create a dual-purpose system. First, you use the heat for clean energy. Then, before you pump the water back underground, you extract the valuable minerals dissolved within it. It's a closed-loop, two-for-one deal with a tiny environmental footprint compared to digging a giant hole in the ground. And this isn't just a theory. It's happening right now. Let's take a quick trip to the Salton Sea in Southern California. Geologists have nicknamed it Lithium Valley because it's sitting on one of the world's largest known deposits of lithium brine. The U.S. Department of Energy thinks there's enough lithium there for over 375 million electric vehicle batteries. Companies and car makers are pouring hundreds of millions of dollars into projects here, using new tech to pull that white gold directly from the brine. Now, let's hop across the pond to Cornwall in the UK. With a rich mining history, Cornwall is now at the center of a new mineral rush. Companies there are tapping into hot granite rocks deep underground, extracting lithium, while also using the geothermal heat to warm thousands of local homes. The potential is global, with researchers exploring similar sites everywhere from Japan and Italy to the Caribbean. And while lithium gets all the headlines because of batteries, these geothermal brines are a treasure trove of other materials. Depending on the local geology, you can find manganese, zinc, silica, and even traces of gold and silver. This ability to co-extract multiple minerals makes the whole process even more economically viable. So, let's talk about the green advantage. It's huge. Because the extraction process is powered by the geothermal plant itself, its carbon footprint is incredibly low. Studies suggest it can reduce the carbon footprint of battery manufacturing by over 47%. The land use is minimal, a compact plant instead of a sprawling open-pit mine. And it uses drastically less fresh water, since it's mainly recycling the geothermal brine in that closed loop. It's a brilliant example of a circular economy, turning a byproduct into a primary resource. Of course, it's not all smooth sailing. This isn't a magic bullet just yet. The geothermal brine is extremely hot, often over 100 degrees Celsius, and highly corrosive, which is tough on equipment. It's also a complex chemical soup, and separating the target mineral without everything clogging up the pipes is a major engineering challenge. Scaling this technology from pilot projects to full commercial production is the next big hurdle. Plus, there are environmental concerns to manage carefully, like the potential to cause minor earthquakes and the proper disposal of any waste. Despite the challenges, the future of volcano-powered mining looks incredibly bright. It represents a true paradigm shift, merging the world of clean energy with the world of raw materials. This synergy could make geothermal energy a more powerful player in the renewable space while providing a secure and far more sustainable supply of the metals we desperately need. The journey is just beginning, But it's clear that the fiery heart of our planet might just be a cornerstone of our clean energy future.